Greetings everyone, this is Non-Expert here, and today we are going to be talking about the observer design pattern. The observer pattern comes under the behavioral pattern classification, and the intent behind an observer pattern is to define a subscription-based mechanism to notify multiple objects about any event or any change that they might be interested in. The best way to illustrate why an observer pattern might be useful for you is by taking a problem statement. So let's say that you're trying to build out an e-commerce app for a couple of stores. Now, for the purpose of this video, we're just interested in two objects, which is the customer who actually buy the product and the store. Now, let's say that there is a new product which is going to be launched in the marketplace and there's a lot of hype around it. Therefore, customers are really interested in this particular product and they want to see when it's going to be available in the store. Now, in order for the customers to get this information, the way they would have to go about doing that is by actually going into the app, trying to see whether the product is actually available or not, and if it is, they can buy the product. Otherwise, they have to keep on repeating the process over and over again until they actually buy the product itself. Now, apart from it actually not being a good user experience, it's also not the right pattern to follow over here. The customers are only interested for this particular one product. Therefore, what they should be able to do is have some sort of a filter in which they can just look at or sort of get notified of any change for that particular product. Now, before we jump into the solution, I do want to talk a little bit about nomenclature itself. Simply because whenever people talk about the observer pattern, they usually use the same semantics and it's best to be on the same page. However, there are a few interchangeable things that you can usually use, but the concept still remains the same. So the object that has the interesting state or the state itself is usually called a subject or a topic. And whatever is actually modifying or updating that particular state is usually called a publisher or a producer or something else. Whatever is actually interested in these state changes or these changes which are happening to the publishers are usually called the subscribers or the consumers. Now, usually when people talk about the observer pattern, they usually think about situations like where you would have to use a distributed messaging queue like Kafka or Kinesis, but for our use case, we don't have to really worry too much about that. So coming back to the problem statement, the way to solve this problem is by using the observer pattern to add a subscription mechanism to the publisher class so that individual objects can subscribe or unsubscribe to the event that they actually want information on. So whenever we talk about like the observer pattern, there are always a few major constructs which will always exist within it. First, you want to make sure that you always have an array field or some sort of a reference of all the subscribers which are interested in a specific type of product. Additionally, we want to give the capability for people to subscribe or unsubscribe from a particular list so that they don't keep on getting bombarded with events which they're no longer interested in. Now, let's take a moment and look at the code. The code itself is not that complicated. I've tried to minimize it as much as I can. The first thing that I did was I created a abstract class and called it subject interface, even though it should be called subject abstract class. But essentially what it's trying to do is it's just trying to like define a few functions which are the attach, detach, and notify functions. Now the purposes of this function is simply that whenever a publisher is controlling or sort of gets an attached request, they can attach a consumer to a particular topic and they can detach them or notify them whenever the functions are actually called. The main meat of the implementation actually comes within the implementation of the abstract class itself. So if you look at the subject, and you can name this to whatever that you want, you can name this as a publisher or a producer, is basically that we have a few class variables which are called as state and observers, which basically represent a dictionary which has a key value pair of the key being the topic type and the value being whatever the change we want it to be. For the observers, we basically make a list of observers which we are actually interested in for a specific topic type. So whenever an attach function is actually called, what we do is we basically add it to the list associated to the topic type that they want to be associated with. So what we can do is that whenever we call an attach, we can say that, oh, this consumer wants information on this specific topic type, so just attach it to that topic type itself. The same logic applies to the detach function as well, where we're just removing it from the list. The notify function basically uses or takes in an argument of topic type, and using the topic type that we've defined before through the state management policies from the self.observers in the state, we can just say that, oh, these are the observers which are actually subscribed to this particular topic, therefore we just want to notify them. Now do note over here that we are actually expecting that there's going to be an observer class or consumer class which is going to have an update function implemented inside of it. Now we can like sort of make a blueprint of that by making another abstract class of observer and then making sure that whenever we define a consumer, we are actually, inheriting from it. But that comes a little bit later. I do want to take a moment to also talk about the sum function functions. Now the sum function is actually not doing anything. It's actually just taking a topic type and using that topic type is just updating the state to some random value. And using that topic type is just going to call the notify function so that all the observers for that topic can be notified of a change which is actually happening. Now again, you can like segregate this out even further into like just making publishers, topics, subjects, and consumers. But for our case, we're not going to like complicate it. Now coming to the observer class, all we're doing is we're just making consumer groups. So we have a consumer group called consumer A, and we have a consumer group called consumer B. Now both of them obviously have to implement the update method because it's an abstract method and they're inheriting from the observer abstract class. However, what's interesting to note over here is that the reason I've created two classes over here is simply to denote how you would actually have consumers in the real world. So let's say for our case, consumer A are people who belong to a different geographical region, such as all consumers which are in India, and consumer B are all consumers which are in the US. Now, in order for us to actually use this function, all we'll have to do is we'll have to instantiate the objects, obviously, and then attach and detach the required observers so that they can like consume the messages as they're coming in. So let's see how that looks in practice. So what I've done over here is I basically instantiated the subject class and made a subject object, or you can call it the publisher or the producer or whatever that you want to. And we've made a few observers as well. Now, observer A belongs to consumer A and observer B belongs to the consumer B subgroup. And after we have that, we're calling attach on the subject itself, where we're attaching observer A and observer B to product A, which basically means that all events which happen in product A will basically be informed of the observer A and observer B class. What that means is that whenever there's any update or any event that happens, these two classes or these two objects are always going to be like notified of that change. And we've also done an attachment of observer B to product B as well. So let's just go ahead and run that. And what you can see over here is that it's just a bunch of print statements to make sure that the attachment of the references is actually happening correctly or not. Now, to actually see this in action, what I'm going to do is I'm going to call subject.sum function. And if you remember the sum function statement, all it was doing was it was just updating the state to some random range of the topic type that is actually being passed in. So the expected behavior over here is that whenever there's an operation that's happening on product A, all consumers of that particular topic will be notified of that change. So what we expect is that observer A and observer B's update class, or the update method rather, will always be called whenever product A is being updated. So let's just go ahead and execute that. And we can see that there is the reaction that we were expecting as we were talking about before. Now, if you try to do the same thing as well for subject.sum function with product B, do remember that we only attached the reference of observer B's object on the product B class, which means that only consumer B group will be notified of that change, as you can see over here. Now, basically, what we want to do is we also want to like look at scenarios where what will happen if, observer A, who's a customer, who's an actual customer, has like consumed that product and they bought the product. In that case, what they want to do is they just want to unsubscribe from the list or the email list or the notification list simply because they don't have any use for it anymore. So what we try to do that over here is basically call the detach of the observer A object from the product A topic type, which will make sure that this particular consumer no longer gets any information on the product A events. So whenever we call some function, we can see that only the concrete observer B, or the object B, or the observer B that we had defined before, is the only one which is actually getting called, and observer A is no longer getting any intimation of any of these changes. Now, that's basically the entire gist of how the observer pattern works. It's a very event driven way of like handling any entries or any changes that you might have, so that basically you're hooking into certain services and triggering or invoking a function whenever you see a particular change. And that's basically it. So let's go ahead and take a moment to look at the pros and cons of actually using an observer pattern. Now, as you can see, that it actually follows the open and close principle, simply because you can add in as many subscriber classes as you want to without actually having to change the publisher code. And the same thing sort of also applies for the publisher code as well, because you can like add as many publishers as you want. Additionally, you can build out these relationships that we were trying to build out, and you can make them a lot more complicated. But the best thing is that they can actually be built out in such a way that they're only running in runtime. So that makes things a little bit better as well for you. The biggest con that I've actually seen of an observer pattern is the control aspect of it. Usually people just use something like Kafka and kinesis, and they all have their own SLAs, and they make sure of a lot of things, and they satisfy a lot of requirements. However, if you're trying to build out your own system, which is distributed in some manner, it becomes a lot more difficult for you to control the update order and how you want to like tell the subscribers whether changes happen, simply because it becomes a little bit tricky. But apart from that, the observer pattern has actually seen a huge boom recently, simply because we are seeing that there's more and more data that's coming into the world, and you only want to get that data if you're actually interested in it. So most pipelines that have been actually created follow this very event-driven policy, where they can like actually subscribe to a particular topic or a specific entity that they're actually interested in, and then get information on that as they want. And that's basically it. Thank you so much for watching this video. If you did like this video, do give a like and do subscribe to our channel. We are discussion over here, and we would love to have you on board with us. Thank you and have a nice day.